The International Payline Group wants to offer you a solution to refuse pollution. This is refuse, waste material with many different classifications: garbage, ashes, unwanted cars and trucks, just to name a few. Refuse has been a problem since the beginning of man. Through the years, we've solved the problem in different ways. Indians found it easiest to pack up their teepees and move to another location. When our forefathers established permanent settlements, they simply unloaded their refuse on a vacant piece of land. Thus, we have the establishment of the well-known dump. Of course, with the dump came thousands of rats, millions of insects, and disease and odor. Today, the disposal of refuse is one of the fastest-growing problems we must deal with. Engineering News and Record magazine surveyed this problem and found the following. In 1916, 95 million people produced 90 million pounds of refuse daily. That's equivalent to 0.9 pounds per person daily. They derived formulas which projected figures showing that in 1986, 265 million people will produce 2.4 billion pounds of refuse, or over 9 pounds per person daily, 10 times as much. Sanitary landfill isn't the kind of business that plugs easily into set formulas. When you set up your operation, there's only one resource to draw on: experience. In the early 1940s, when the military was experimenting with the first landfills, International was called in to participate. And through this early cooperation with the government, we invented the ramp method. It was also during this period that International and Drott introduced the bull clam, later to develop into the multi-purpose bucket. Our close involvement in the landfill industry since its beginning has convinced us that it is the most effective way to cope with the refuse problem, and is being used in most of our communities today. Keep in mind that a landfill is not an earth-moving project, and by all means it is not a dump. Its attraction is a result of the advantages it provides over the other waste disposal methods. Let's take a look at some of its advantages. Low initial investment. The basic requirements are a piece of land, equipment, and a well-planned program. Management is a must. Low operating costs. The equipment ownership and operating cost and necessary manpower is really all there is. Complete and final disposal of refuse. There is no leftover refuse at the completion of a landfill operation. It's neat and complete. Increases land value. Using wasteland gives the community an opportunity to improve the land for useful purposes such as parks, subdivisions, or industry. It's easily expanded. This method is flexible enough to easily adapt to the changing conditions of the community. Additional land is all that is needed. There is no pollution. Landfill operations do not add to one of today's biggest problems, in other words, air and water pollution. It's quickly established. As soon as the equipment arrives on the site, the operation can begin. There's no lag time to contend with. It also controls fire hazards. By not letting refuse lay around, the chances of fire are virtually eliminated. But most important, a sanitary landfill operation eliminates rats, insects, and other vermin, not forgetting the problems they cause. From an economic standpoint, two of these advantages, initial investment and operating costs, appear to be the most attractive. A closer analysis of the two explains why. Land. Ideally, marginal land can be obtained at reduced cost. But whatever the cost of the land, a large portion of this expense can be recovered through a higher resale value after it has been reclaimed as a result of the landfill process. Planning and designing. A first-class consulting firm can provide the necessary expertise in the planning and design of your landfill, including testing, geology, and subsurface evaluation. Any land purchase should be contingent upon subsurface exploration. The consulting firm is also aware of and can cope with the legal and political issues which will surely arise. Site development. land clearing, drainage features, building access roads, installing utilities, fencing, and landscaping are all functions which must be performed before the first load of refuse is dumped. Facilities. You will need administration and restroom accommodations for your personnel, as well as a maintenance shelter for equipment. Equipment. Equipment, which will be discussed later, can be your largest initial expenditure. In the operating costs area, the first item to be considered is personnel. Relatively large landfills can be effectively operated with minimal personnel requirements. Equipment. Equipment owning, operating, and maintenance costs are about 40% of the total operating costs. Miscellaneous. These costs, administration and overhead, for example, make up only about 10% of the total. By necessity, this analysis is very general in scope and will widely vary according to the size, type, and operational efficiency of the individual landfill. For example, lack of cover material and/or use of a landfill method requiring excess handling of cover material might significantly reduce the profit margin of an operation. However, careful planning will help assure an efficient operation. Careful planning begins by selecting the proper landfill method. That is, how can the refuse be most efficiently buried on the property selected? Initial questions must be answered, such as, what methods are feasible for the community, and what are the limitations of each? What are the overall costs of each method? A successful solution for one may not work for another. Improper application of a method to your operation could be disastrous. Let's take a look at the available methods for disposing of daily refuse. Basically, there are three methods to choose from: the trench method, the area method, and the ramp method. Analyze your needs. Don't let other landfills dictate your requirements. The method you select should depend entirely on the site. Choose the one that allows you to operate at the least expense. The trench method is best suited for level or gently sloping land where the water table is not near the surface. If you're considering this method, remember that there is the need to handle cover material twice: excavating and stockpiling, and then filling. This is an added expense. There are three ways to work your trench, depending on how you choose to excavate. One approach is the single progressive trench. In this technique, the trench is excavated only far enough to provide working space. As cover is needed, the excavation is continued. Since only 1 part cover is used to 4 parts refuse, you will constantly be faced with excess material. A second approach is the single trench. In this approach, the entire trench is excavated. Cover material is windrowed along the trench sides. Excess material is removed all at one time. The windrows also act as wind breakers to cut down blowing papers. Additional help can be obtained by placing the working face on the windward side of the trench. The third approach is the dual trench. An entire trench is excavated and the material is disposed of. A second parallel trench is begun at least 2 feet away from the first. As the second trench is excavated, it provides cover for the first. In this manner, trenches are consecutively dug until your site is exhausted. The area method is best suited for flat land where the water table is near the surface. While using this method, cover material will probably have to be imported. This acquisition and added dirt handling can be a considerable expense. To begin, a small knoll of material must be formed. This will form your initial working face. Refuse cells are progressively formed, one lift at a time until the area is brought up to the grade you desire. Cell walls are formed by the adjacent cells. The area method is nothing more than a special condition of the popular ramp method. Inability to dig downward and the lack of a natural working face dictate its use. The ramp method is the ideal approach. No dirt moving or advanced preparation is necessary. The side of a natural depression can be used for an initial working phase. Although the water table should be considered, this is not nearly as critical a problem as it is when excavating trenches. Refuse is dumped at the base of the ramp. The amount or number of loads dumped depends on the ramp size, the equipment size, and the daily tonnage to be handled. The refuse is then spread up the ramp in a layer not more than 2 feet thick and compacted into a layer not exceeding 6 inches. Generally, a compaction ratio of 4:1 is sought before additional spreading takes place. The procedure is repeated until the end of the day or until the cell reaches a height of 8 feet. At that point, cover material is spread over the refuse and compacted to a 6-inch layer. At the end of the day, this is how the landfill should be left: clean and odorless, with no pests. No dumping should be allowed until morning, so that each day's deposit can be completely sealed with 6 inches of compacted cover material. While discussing landfill methods, we mentioned compaction of refuse. Proper compaction is critical for good final results in a landfill project. Let's take a closer look at compaction relative to construction equipment. Flotation and compaction are inverse functions. That is, the more capable your equipment is in obtaining one, the less capable it is in obtaining the other. Compaction is achieved from the proper combination of weight and pressure. A concentration of weight over an area provides the pressure necessary for compactive effort, or PSI. The smaller the area of concentration, the higher the PSI. Because of its design as a flotation machine, a crawler dozer's compactive effort varies between 9 and 11 pounds per square inch. A crawler loader achieves slightly higher compaction than a dozer in its same horsepower class. This is possible because the shorter track of the loader allows the total weight of the machine to be concentrated over a smaller area. A rubber-tired payloader can obtain as much as 3 times the pressure of a crawler machine. This results from the payloader's tire contact area being considerably smaller than the track on ground of the crawlers. However, a high PSI can be obtained from the so-called ironing action of a crawler loader equipped with a multi-purpose bucket. The operator rests the loaded bucket on the refuse, applies slight down pressure, and drives forward. The weight of the machine with loaded bucket, hydraulic down pressure, and the thrust of the machine, all concentrated on the bucket compaction plate, yield ground pressures in excess of 50 pounds per square inch. This is the most efficient method of compaction when using crawler loaders. Now, after you've chosen the proper method for your operation, it is time to make the most critical decision in making your landfill a success: machine selection. The real cause of an unsuccessful operation can almost always be traced back to improper machine selection. The sanitary landfill planner has 2 primary considerations when selecting equipment: the size, the type. In earth moving, it's fairly simple to determine the size of the equipment which it will take to move all the material in pile A to pile B in a given time. The material being handled is easily classified, fairly consistent, and the production requirements are known. Refuse, on the other hand, is a mass consisting of garbage, trash, construction debris, and other assorted wastes. Incoming volumes may vary considerably, and fluctuations are unpredictable. How much daily cover material is required? How far must you transport it? There are no definite rules in equipment selection. There is only experience, and International, with its distributor organization, is the most experienced in the business. We suggest the following general guidelines based on population and average daily tonnage. These tonnage figures are based on 5 pounds per person per day, the current national average. But a word of caution here. Refuse is currently being produced at a disproportionate rate to normal population increases. Therefore, the equipment you choose should have the capability of handling approximately 25% more refuse than is currently being generated. Dirt moving distances, population size, and the method you choose for operation will be the primary concerns when selecting equipment. This selection breaks down into 4 categories: crawler dozers, crawler loaders, rubber-tired loaders, and scrapers. Crawler dozers are well suited for ramp and area fill methods. Up to about 300 feet, the dozer will effectively excavate and transport cover material. Beyond that distance, other equipment becomes more economical. It is a machine capable of preparing the site, spreading, compacting, covering, building and maintaining access roads, and land clearing. Its excellent flotation and tractive ability make it an all-weather machine. The crawler loader, especially when equipped with a multi-purpose bucket, is also an excellent tool for the area and ramp method. In addition, its highly efficient excavating capability makes it ideal for trench operations. For example, since the bucket doesn't extend outside the tracks, higher compaction is obtained close to the trench walls. Like the dozer, it is capable of functioning regardless of climate. Maximum cover haul distance is about 300 to 500 feet. Mobility and versatility are key words if you select a rubber-tired loader. As a result of its high-speed design, cover material haul distances in excess of 600 feet are economically feasible. A big advantage, of particular interest to smaller communities, is the potential of roading your payloader to other job sites during those periods when the landfill is not in operation. Scarcity and excessive requirements of cover material dictate the necessity of payscrapers. These high-speed machines make it possible to quickly move large volumes of cover over long distances. The elevator design provides large quantities of fluffed material, which is more easily compacted. The open bowl is perfect for excavating and stockpiling large volumes of cover for larger operations. The scraper can also assist in excavating trenches if necessary. We said earlier that compaction and flotation were inverse functions. Nowhere is this more evident than when production must continue even in inclement weather conditions. A crawler is capable of operating under wet, muddy conditions where a rubber-tired loader might encounter tractive difficulties. Also, since the tires will penetrate deeper into saturated refuse, the machine's weight is distributed over a larger area, and the compactive effort is less. Thus, the compaction advantage over a crawler is reduced. A sanitary landfill is the most adverse application in which construction equipment operates, bar none. To better protect the machines when working under the hostile conditions of the landfill, we provide various attachments. For example, a ROPS canopy with seat belts is standard equipment on international machines. But an added safety feature in the form of our canopy rear screen could be a wise investment. In addition to protecting the operator from flying debris, it also serves to protect the fuel and hydraulic tanks. To ensure operators' safety and comfort, we offer a deluxe ROPS cab. This cab isolates the operator from dust, precipitation, and extreme temperatures. One of the more prevalent dangers on a landfill is radiator clogging. This causes overheating and could result in serious maintenance problems. A valuable aid in combating this problem is our reversible pitch fan. A quick adjustment reverses the airflow for fast and effective assistance in cleaning the radiator core. For added protection and longer life, we suggest the armored core radiator, which is standard on crawler loaders. This radiator is better able to withstand the sandblasting effect created by those ever-present minute particles. Vandalism can be effectively decreased with our vandalism protection attachment. This attachment consists of a lockable exhaust rain cap, locking filler caps, and padlocks for the radiator cap, toolbox, hood access door, and instrument panel guard. To facilitate the fast and efficient pavement of large volumes of relatively light material, we replace our semi-U blade with a Young or Rockland blade. Our counterweight drawbar combines the added weight necessary to increase compaction and provide better balance with the extra benefits derived from a drawbar. In light of the almost continuous operation on slopes and unstable materials, the counterweight adds to the loader's balance, while simultaneously providing increased compaction. To keep the machine operating longer between fuel stops, we offer an increased capacity fuel tank. This tank provides approximately 1/3 more fuel to significantly reduce the costly idle time spent in refueling. The widespread presence of all types of wire and plastics pose a continuous hazard. These materials have an uncanny ability to work themselves into areas where they can cause considerable damage. Our guard package, including a sprocket drive seal guard, a severe service crankcase guard, transmission guard, and pivot shaft area guards, provides protective barriers to help prevent damage. The severe service undercarriage, with all its beefed-up components, provides the added strength and durability necessary for long life on a landfill. Our perforated hood and engine side enclosure sheets serve a dual purpose. They permit unrestricted airflow and prevent debris from entering the engine compartment. The perforated hood is unavailable for loaders. Track frame covers provide protection for the hydraulic track adjusters without the undesirable side effects of accumulating trash. The multi-purpose bucket with teeth makes a loader the most versatile machine on a landfill. With this bucket, you can obtain the combined work efforts of a dozer, clam, or scraper in addition to those of a loader. Whatever type you choose, equipment will be your greatest single expenditure, so act wisely. The right selection will make your landfill a success. Remember, a landfill can be as elaborate or as basic as the community wants. No matter what size, the advantages of a landfill are twofold. Not only have you handled the problem of refuse, but you've given the community a piece of land that can be used for parks, homes, or industry. Or the land can be sold to recover part or all of the initial investment. This piece of reclaimed land might have still been useless were it not for a landfill. Let's look at what others have done with landfill sites. Sears Roebuck built this 10-story building in Memphis, Tennessee, on land that was once the Memphis landfill. This is Milwaukee County Stadium in Milwaukee, Wisconsin, resting on 95 feet of landfill. The Milwaukee Brewers play home games here. Football stadiums have been built, and housing has been constructed on land that was once a swamp. This is one of the numerous parks that have been built on landfills all over the country. We've mentioned only a few of the ways a landfill could benefit you. Can a community leader deny his community the opportunity to economically, cleanly, and efficiently deal with this rapidly growing problem? Not only deal with it, but reap benefits from it. This bothersome, useless refuse pile today could be this beneficial playground for your children tomorrow. This, then, is our solution to refuse pollution.